you to do right now to get us ready to solve exponential equations is I want you to fill out as much of this table as you can. Like I said, that would be 4, 2 squared, 3 squared is 9. Fill out as much of that table as you can. You only have to get to 1,000. If you at any column as you're going down here, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. At any point, if you get to 1,000, stop. Okay, on any of these. You don't have to keep calculating unless you're just enjoying it so much that you want to keep going. Okay? You're going to use this a lot today. Okay? Off you go. Anyone remember how to do this on your calculator? Yeah. Rather than doing individually, going into your y equals menu, if I want to do x to the 4th, I just put in x to the 4th. And then I go to my table, second graph, and I've got them all right there. 2 is 16, 3 is 81, 4, 256, 625, 1296. It's a lot easier, man. Work smarter, not harder. And if you wanted to, you could put these in. I know I said you didn't have to go any further, but...
Is that true in all circumstances?
What?
Work smarter, not harder?
No. These are getting insanely big. I'm just going to stop here in a minute. I know I said you didn't have to go over 1,000, but I'm having so much fun. I wanted to write 100,000.
Hey, for 10, I believe it goes up to 10 trillion. Oh, speaking of that reminds me. One of the warm-ups we had for the first period, Michael was only off by about 25 trillion.
It's quite a bit.
Yeah. I guess that's what happens when you input the numbers wrong. That's what I did, but when I went back to check it for column 2, that's not what I got.
All right. Okay, with that being said, I want you now to go to your exploration, page 188 of your student journal. Okay? Exploration number 1. How can you solve an exponential equation graphically? You're going to work with a partner. Use the graphing calculator there. Make sure you put something in the spot there to hold it. Okay? Ideas on how to do it?
7.
Hey, guys, just a quick reminder on how to graph these. You're going to your y equals menu. So hit y equals. Okay, if there's something in there, you can clear it out. I'm going to put in 2 different equations. First, I'm going to set this side, just like we did earlier in the year. I'm going to set that first side equal to y. And then I'm going to set this side equal to y. So 2.5 x minus 3 equals y. I'm going to call that y sub 1. And then y sub 2 is going to be 6.25. Now remember, the 2 and the 1 just means my first equation with y and my second equation with y. I'm going to plug both of those into my y equals menu here. So we got 2.5 x minus 3. Oops. Yep. 2.5. Let's try that again. To the x minus 3. Okay? It's a little blurry there. Okay, and the next one, y sub 2, we're going to say 6.25. Okay? Everyone make sure your neighbor has it plugged in. If they don't, and you can't help them, raise your hand so I can come around and help you out. Here we go. We're going to hit the graph button. We got graph. Okay, now if your picture does not look like mine, then that means you're zoomed in a different spot. So just hit zoom, the zoom key, and zoom 6 is standard. That brings you back to your normal window. So now it should look like mine. Okay. Tell your neighbor where the solution to this equation or this system is. Whose phone is beeping? I think it's over here. Is that your phone? Oh, yeah, that'd be good. Okay? We good? Volunteer, where's the solution? Yes? Where? Okay, how do we find that?
It's where they
It's where they intersect or cross. Okay? So we got to use our calculate key. So we're going to go to second, trace, which is calculate, and we're going to calculate which one? Number 5, intersect. It's saying which one's your first curve? And y sub 1 is my first. Which one's my second? Well, 6.25. And our guess, you just need to move that cursor as close to that point of intersection as you can. There we go. Looks like x equals 5. How do we know x equals 5? Well, it says x equals 5 here. Do we worry about that? Nope, because all they're doing is asking for x. So x equals 5. Okay? Explain the process. You can go through and explain what you did there. Okay, or how we use our graphing calculator to do that. Okay, you should probably summarize that info down here. All right, I'll give you a couple minutes to do that. All right, exploration 2. Use your graphing calculator to graph that equation. And then in the same viewing window, so in the same picture, part B, graph a linear equation, if possible, that will not intersect that. So a line that will not intersect it. So it may help you if somewhere on this graph you're like, well, I know if I could graph this line or this line or this line, it won't intersect it. So maybe draw the line that you don't want to intersect it. And then in the same viewing window, graph a linear equation, if possible, that intersects in more than one point. Okay? You have to come up with the equations. All right? You work together. Here you go. Asking for the equation line. Can anyone draw a line that will not cross that graph?
Yeah.
Cassie, where would that line be that won't cross the graph? Okay, so give me some directions here. Parallel, can't make parallel to that. Has to be a straight line. Jason, you want to help out?
How about y equals -4?
Y equals negative, could I go like y equals, so it'll fit like y equals -1?
Yeah.
Okay. Any -4 would work, I just couldn't show it. So that line will not cross. I agree. Okay, and that is y equals -1, but Jason's y equals -4 would be fine as well. Okay, so if we were to graph that, that one would not cross. What would we call that in terms of solutions there? Yeah, no solutions. Does not intersect is a no solution. Okay, well that would mean, by the way, if y equals 2 to the power of x and y equals -1, that's saying 2 to the power of x equals -1. Can a power ever equal a negative? Nope. That's why it's a no solution. Okay, in the same viewing window, is there a way to draw a line that will intersect this graph twice?
Yes.
Anyone figure that out? You did?
If it's y equals -2 to the x power, it'll split at the same point.
Oh, but it's got to be a line. Yeah. So you did a curve. We just want a straight line. Jillian?
Y equals 0.
Y equals 2x plus 2 or x plus 1, I guess. Same thing. Yeah. Okay.
It could be y equals 0.
2x plus 2. Let's see. 1, 2. Get it all hammered out, Aaron? Okay. That was pretty fast. All right, good. Were there a lot of people down there still? That's why I sent you guys later. All right. Hey, so yeah, if we continue that up, it would hit right there, and it hits right there. So could you have multiple solutions? Yeah, you could. You could have more than one solution. So it is possible to have more than one solution. Example would be that line, y equals 2x plus 2. Okay, so we've already answered question D. Is it possible to have no solution, more than one solution? Kind of we went through that. All right, so as we go through and solve these equations, we need to be looking for one solution. We need to be looking for two solutions. We need to be looking for no solution. I want you to take a look at exploration number 3, next page.
So there was 2 solutions on the test.
Yeah, no, that's not one. That was just a poorly worded problem on that one. Okay, exploration number 3. Use the graphing calculator to solve each equation. All right. Set them both equal to y. Y sub 1, y sub 2. Find the point of intersection. If you're struggling, make sure you talk to me. Okay, let's see how we did on them. So, first column. Or first row, excuse me. X equals -1, no solution, and x equals 1/2. How many got all 3? Okay. Well, letter D through F. 2, no solution, and 1/4. Okay, and the last 3, what do we have?
-4,
-4, and the last one is 2 solutions. 2 and 4. Now on that last one, I realize some of you didn't get to that one, so I want everyone to put that last one into your calculator. Okay? Go ahead. If you've already done it, it should be pretty quick. Okay? We're going to go 2 to the get up there. 2 to the x minus 2 and 3/2 x minus 2. We hit graph. Please note on this one, you'll see it intersect in 2 different places. As you figure that out and you do your calculate, and number 5, first curve, enter, but this next one where it says guess, since there are 2 solutions, you got to move that cursor closest to the first point of intersection. Whoever's talking back there needs to be done talking. Okay? Closer to the point of intersection you're trying to figure out. So I'm going to move it to there. I hit enter. That's going to give me like a lower point of 2. Okay? And then I've got to go through that same process again. Okay? First curve, second curve, and then move my cursor closer to the other point of intersection to get that one. So that one will give me the 4. Okay? 2 and 4. All right, I want you to summarize right now on the bottom. How can you solve an exponential equation graphically? How can you use your calculator to do it? Okay? Because the next step, we're not going to be using our calculator. Off you go. All right. I want you guys to go ahead and turn to page 191 of your student journal. It's the next page. We're going to try some of these without our calculator now. So if you have your graphing calculator, fantastic. Just you're not allowed to graph these right now. Okay? We're going to go through number 1. Solve each equation. Check your solution. Number 1. I want you to tell your neighbor what we have in common there.
Wait, can you use the calculator but not in the program?
Correct. Okay, what's in common, Vincent? What do we have the same? Thank you, Vincent. Way to throw your voice over to the other side of the room. I was impressed. Nice job. Okay, you even changed the sound of it. Okay. All right. Vincent, do you agree it's 3?
Yeah.
Yes. The 3 is in common. What do we call that? Someone else. Special name. Yes. That is our base. When your base is the same, then the exponents must be the same if it's set equal. So if I said, for instance, if I said 2 to the, whoops, you guys should see that, 2 to the second equals 2 to the x, okay? Or better yet, let's make that a third. That way we're not confused with the 2. 2 to the third is equal to 2 to the x. What does x have to be? 3. Because they have to be the same. They're equal. Okay, well this says 3 to the 4x equals 3 to the 12th. Well, that means 4x must equal 12, which means x is 3. Because the powers have to be the same because the bases are the same. Okay, so when you're going through these, the first thing to ask yourself is the base the same? If it is, then just set the powers equal. I want you to try number 2 and 3 on your own, please. Okay, base is the same, correct? Both 8. So we're focusing right here. X plus 5 must equal?
1024.
X plus 5 must equal 20. Therefore, x is? 15. If the base is the same, just take the powers and set them equal. 4x minus 5 must equal 2x. Okay? You have to be able to solve that. Collect all your x's on one side, so if I move these 4 x's over, I've got to subtract them over, I end up with negative 5 equals negative 2x, so x is, divide by negative 2, x is 5 halves. Okay? Set the powers equal. Now, if you can't do that, you're struggling with that, then you know how to use your calculator. Yeah? Terminating, it's fine here. So if you said 2.5 right here, that would be okay. 2.5. That'd be okay. But if it doesn't terminate, you can't do that. Yes? That's a good question. That's what I would be asking too. How do I do it when the bases aren't the same? So let's move on to number, say like, let's go to number 7. Bases are not the same. When the bases are not the same, our goal is to find a common base. Okay? So if the bases are not the same, find a common base. Now if you look at that sheet you picked up on the way in, there's a little flow chart on the back. You turn it over. It's like gives you some steps here. It says, hey, read and analyze the equation. Are the bases on each side the same? If you say yes, write the equation by setting the exponents on each side equal to each other and solve the equation, and then check by using your graphing calculator, substituting in. This is on the back of this page, right? The one we filled out on the way in. Okay, now, as Logan asked, what happens if the bases are not the same? Base is the same? No. Rewrite each side of the equation so that the bases are the same, and then do the same steps that you had if they were the same. So when I'm looking at this, hey, 4, if I take, everyone look at the table you actually filled in. Okay, take a look at all the numbers you have in there. Okay, so here's mine. I know that 4, it falls under this category. 2, it falls under this category. Okay, the question is, can I find 256 and make that, can I make this into a base 4? So in other words, if I go to 4 here, does 256 end up in this column? Yeah, it's 4 to the 4th power. This is, 256 is 4 to the 4th power. Okay, it's 4 to that power. Okay, so I could rewrite 256 as 4 to the 4th. That is the same as that. And now what I have is 4 to the 7 minus x equals 4 to the 4th, or 7 minus x equals 4. And so x equals 3. Okay, so you have to be able to match up those bases. Say I'm trying number 10. Can any one be written as 9 to a power? Yeah. What power of 9 is 81? That's 9 to the 2nd. Now notice, I circled that. I'm going to put that in parentheses. That's 9 to the 2nd to the 3x power. So I've got to rewrite it. And I know we get in a hurry when we're doing these. But don't get in so much of a hurry you mess yourself up. This power, we have the same base now. This power is x minus 4. What is this power? Talk with your neighbor. What's that power?
6x.
As a power to a power, so it is 6x. Subtract our x over. Divide by 5. Okay? Negative 4/5 there. Your assignment today, using your power sheet, not your calculator, your assignment is to finish 1 through 15 on page 191 and 192. 1 through 15. Okay? 1 through 15 on page 191 and 192.